Hello everyone, I am Mahin Fatima studying in 2nd CSM in Srinivas Ramanujan Institute of Technology. My advanced data structures and algorithm analysis topic is 0 by 1 knapsack problem using branch and bound. Let's go into the topic. Branch and bound. The term branch and bound refers to all state space search methods in which all children of the E node are generated before any other live node can become the E node. In backtracking, we used depth first search with pruning to traverse the virtual state space. The branch and bound method is a systematic way of exploring the solution space. It includes dividing the problems into smaller subproblems, branch and bound, calculating bounds for these subproblems. This method helps in pruning branches that cannot yield a better current best solution. In branch and bound terminology, a BFS like state space search will be called out FIFO. First in first out search as a list of live nodes is a first in first out list, or queue. FIFO search coupled with bounding functions is called FIFO. Branch and bound. A D search like state space search will be called LIFO. Last in first out search as a list of live nodes in a last in first out list or stack. LIFO search coupled with bounding functions is called as LIFO branch and bound, BB. Next, a search strategy that uses a cost function c power x equals to f of h of x plus g power x. To select the next E node, we'd always choose for its next E node a live node with least c power x. Hence, search strategy is called least cost search. Least cost search coupled with bounding functions is called least cost branch and bound. Applications of this are 0 by 1 knapsack and traveling salesperson. Next, introduction to 0 by 1 knapsack problem. The 0 by 1 knapsack problem is a classical optimization problem in combinational optimization. The objective is to maximize the total value of items packed in knapsack without exceeding its weight capacity. Each item can either be included in the knapsack 1 or not included 0, hence the name 0 by 1. Here is one example of 0 by 1 knapsack problem. In this figure you can see it here. Next, problem definition. Given a set of items each with weight and value, a knapsack with maximum weight capacity. The goal is to determine maximum value of items that can fit into the knapsack. The problem is NP complete, meaning it cannot be solved in polynomial time with large inputs. Next, 0 by 1 knapsack problem using branch and bound. 0 by 1 knapsack problem is a well-defined optimization problem where given set of items each with a weight and value, you are tasked with determining the most valuable subset of items that fit into a knapsack with specified weight capacity. The problem is called 0 by 1 because you can either include an item in the knapsack or not, that is fractional part of items is not allowed. Steps in branch and bound for knapsack. Step 1. Involving sorting items based on their value to weight ratio to facilitate optimal solution. Step 2. Consists of creating a decision tree where each node represents including or excluding an item. Step 3. Applying bounds to eliminate nodes that cannot yield a better solution than the current best. Next, the branch and bound technique is an efficient approach to solve this, systematically considering which items to include or exclude from the list. Here is an overview of how branch and bound method works for the knapsack problem. Next, 0 by 1 knapsack problem. To use branch and bound technique to solve any problem, it is first necessary to conceive of state space tree for the problem. We have already seen two possible state space organizations for the knapsack problem. Still, we cannot directly apply the technique of section since these were discussed with respect to minimization problems, whereas the knapsack problem is a maximization problem. This difficulty is easily overcome by replacing the objective summation pi xi by the function minus summation pi xi. Clearly, pi xi is maximized if minus summation pi xi is minimized. This modified knapsack problem is stated as minimize minus summation I equals to 1 to n pi xi subject to summation I equals to 1 to n wi xi less than or equal to m, where xi ranges from 0 or 1 and I ranges from 1 to n. Next, algorithm of this branch and bound. We have wi, pi are respectively weights and profits of ith object. B equals to cp, c equals to cw. For I equals to k plus 1 to n, do if c plus wi less than or equal to m, then c equals to c plus wi, b equals to b minus pi, return b. Next, example of 0 by 1 knapsack using branch and bond. Consider a knapsack with capacity of 50 with items having various weights and values. The branching process will explore different combinations of these items while calculating upper bounds. This results in an optimal solution, maximize value without exceeding the capacity. You can see this example in this figure. Here we have capacity of 50 items with different weights and values in this figure. Next, advantages and applications. The branch and bond method is efficient for solving the 0 by 1 knapsack problem for moderate sized data sets. It is widely used in resource allocation, budget management, and logistics optimization. This method provides an optimal solution while systematically exploring feasible options. So that's all about this 0 by 1 knapsack using branch and bond. Thank you for giving me this wonderful opportunity. I hope you found this session insightful. Have a nice day.